So I'm going to work through the solution for problem number 2 on the final exam for fall 2010. And in this particular problem it says for problems 1 through 3, it's defining the function f of x as a compound function where we have from x less than 0 is going to equal to 2 divided by e to the negative x plus 1. For x between 0 and 3, it's going to be the square root of x plus 1. And for x greater than 3, we're going to have f of x is equal to x plus 2 divided by x squared plus 1. So the intervals for the parts of the function are going to be from negative infinity to 0. And this one's going to be from 0 to 3. And this one's going to be from 3 to infinity. And the problem states for problem number 2, f of x has a jump discontinuity at x is equal to what? And basically, this is, if you look at the answer sheet, or I'm sorry, if you look at the question, it gives you option for 0, 0 and 3, or 3 only, and part D has no jump. Part D says it has no jump discontinuities. So what we want to do is see what's happening at x is equal to 0, 3, negative infinity, infinity. So what's happening to the function as we approach these numbers. And also we want to look at whether these functions, the parts of the functions, are defined in the given interval that we have. So let's first check for to see if the various functions are defined on the given interval, and we can do that by simply looking at the function and saying, what is it about this function? Is there anything about this function that's going to make it the function not exist? Well, that would only be if the denominator is equal to 0, and we see that since we have an e raised to the x, that there is no number that we can put in for x that's going to give us 0 in the denominator. So, and in this particular interval from minus infinity to 0, so we don't have to worry about this part of the function. It exists for all the real numbers in between negative infinity and 0. So we look at this particular part of the function, the square root of x plus 1. Again, the square root is only defined for positive values, but this particular part of the function is only defined for 0 to 3, which are all positive, so this is fully defined. We don't have to worry about this one. This particular function is where the denominator, we have to worry about if the denominator is equal to 0. Since we have a squared term here, it doesn't matter if we have positive or negative numbers. We're always going to get a positive number on the denominator in the interval between 3 and negative infinity, and so we don't have to worry about that. It exists. Every number exists for this particular function. So now we just want to evaluate, look at the function and see what's happening when x is approaching 0, 3, negative infinity, infinity. So to do that, we want to take the limit as x is approaching that particular number. So let's do the first one where we have the limit. And we want to look at the limit as x approaching this number from the right and the left. So we say x approaches 0 from the left, and we have the limit as x approaches 0 from the right. Now, the only thing that we have to do now is determine which part of this complex function that we need to put in as the limit that we're trying to evaluate. So if we're approaching 0 from the left, then we want a number that's close to 0 but slightly less than 0. So that's going to put us in the negative range. So that means we're going to be looking at this part of the function. So we write the limit as x approaches 0 from the left of 2 divided by e to the negative x plus 1. And in the same way, we want a number that's close to 0 but slightly bigger than 0. That puts us in the positive range of 0 to 3, so we want this part of the function. So we get the square root of x plus 1. Now we just need to evaluate these limits, and we can do that by substitution, direct substitution. So when we do that, we get the limit as x approaches 0 from the left of 2 divided by e to the 0. Well, that just goes to 1 plus 1, which is 2 over 2. So this limit is just 1. And we do the same thing, direct substitution on the bottom one. X approaches 0 from the right of the square root of 0 plus 1, which is basically the square root of 1, which is 1. Now, as we're approaching 0 from the left, the limit approaches 1. As we approach 0 from the right, the limit approaches 1. That means that these two limits are equal. So that means the limit at 0 is actually 1, and the function is continuous at 1. So we do not have a discontinuity there. So let's do something similar for what's happening when x approaches 3. So again, we can write the limit as x approaches 3 from the left, and the limit as x approaches 3 from the right. And we need to determine what part of the functions that we need. So as we're approaching 3 from the left, we need a number that's slightly smaller than 3 but really close to 3. So that puts us in this range, this interval. So that's going to be the square root of x plus 1. And for this, as x approaches 3 from the right, we need a number that's slightly bigger than 3. So that's going to be in this range from 3 to infinity. So we use this part of the function, which is x plus 2 over x squared plus 1. And we can evaluate these limits through direct substitution. So we take the limit as x approaches 3 from the left with the square root of 3 plus 1, which is the square root of 4, which is 2. And this limit is the limit as x approaches 3 from the right of 3 plus 2 over 9 plus 1, which is basically 5 over 10, which is 1/2. Okay, now we see that as we're approaching this function from the left, we get a value of 2, and from the right we get a value of 1/2. These do not equal. That means the function is jumping from 1/2 to 2 or from 2 to 1. There's a discontinuity there. So we're definitely going to have a jump discontinuity at 3. So this particular one for 0 we have no. Here we have yes. Okay. So in this particular problem, when you're looking at the possible choices that you have for answers, there isn't anything about infinity or minus infinity, but you know, if you had a different problem, you might want to check to see what's happening at minus infinity and infinity as well, in order to determine if you have you know, discontinuity at those boundaries. So in this particular problem, we don't have to worry about that. So the answer is actually C, 3 only. So the answer is C, 3 only.